Hi, how familiar was that scene? Sitting about with your scraps of paper and coffee and just thinking about your what ifs and your buts and the hows and where do I start next? Well, I finally got the C-beam laid out exactly how I wanted it. So now it was time to design the corner brackets. But I couldn't just use my head and scraps of paper. There's a bit of software like CAD programs, etc. that we need to use. So to start off this video, I'm just going to show you how I've got mine all set up. So if you want to follow on and design and use the stuff that I'm using, you'll know exactly what I'm using and where I got them from. So let's take a look. First of all, I'm going to create a folder on my desktop, and I'm going to call it Spartacus. Everything I put in this folder will be uploaded, so whatever you see me put in there you can download and play with yourself. Now the CAD software I'll be using is going to be SolidWorks. There's a few reasons for it. I come from a background, I've used a Libre design a lot, and in fact I still use it for some 3D stuff, but it's cut down version called Cubify. I use that for a lot of me 3D stuff because, you know, it's really good. Although I'm moving across to SolidWorks on the 3D stuff, to me SolidWorks and Cubify are pretty similar. Another big problem I had is I can't get on with SketchUp. I just can't get on with it. There's so much stuff on there for SketchUp, say like Mark's put on, and a lot of other builds are in SketchUp. I just can't get it, especially that little tape measure thing. So anyway, I'll be using SolidWorks. Now, one of the more important things you need to do is go to the Open Builds website, join the Open Builds, just have a look at some of the stuff that is on here that's being built. And this is all being built by Open Build stuff originally. There might be some customized parts in there, but it all originates from what you can see in here. Well, my first port of call is to go to the resources and have a look at some of the stuff you can download. Now I'm going to be using this library here, the SolidWorks 2014 library. I'm not going to include that. In fact, yes I will, I'll upload it. If I get any problems from Rob, then I can soon delete it. But Rob has done a fantastic job with the libraries here if you're using SolidWorks, but he's got Aegis versions, step versions. If you're using SketchUp, then you'll find the whole Open Builds parts. There you go, there's a SketchUp library there, which is all the parts. It's actually posted by Mark, that one. So it's exactly dimensions and everything that he's going on. So you can use SketchUp, you can use SolidWorks, loads of other programs, and download, and you can test your ideas on the screen before you go ahead and do anything. So one of the first things I need to do is decide what wheels I'm going to have on my Y carriage, whether they're going to be a small one at the top or a small one at the bottom. I could use both of the centre rails, you know, have them all mini V wheels. I could double them up. I could use big wheels. Now, I had problems there deciding which ones I was going to have. The reason why I needed to know these before I made the brackets is, now if you remember on the Ox with a big wheel at the bottom, you couldn't use a piece of 20x40 laid on its side because the wheel was too big. So then that would restrict us, or restrict me, from having a big wheel on the bottom. It means I would have to have piece of 20x40 stood up exactly the same as what is on the Ox at the moment. So after downloading the parts library, for the open build stuff, I decided to have a little play putting bits together. So I started off with a 40x20 stood up, and then I added corner block, a 90 degrees corner block to one side of the C-beam and a 90 degrees plate on the other side, and of course we had to have a C-beam end plate. This gave me a general idea of what I was looking for. So this is what I come up with: 20x40 laid on its side, 10mm substrate and a corner block to hold it down. We'll add in the C-beam end plate and remove the holes for the stepper. Take off the end that we don't need, add a plate at the bottom and cover up the corner block. Originally it's in 12mm, so we'll cut it down to 6mm and round the corners off nicely. And this is the final product. This is what the front plates are going to look like. But let's have a look. How did we put something like this together? Where did we get the measurements from? So let's create our first end plate. So I'm going to go and open. This is in the parts library from Rob that I downloaded. We go into the plate section, C-beam end mount. We can now get all the dimensions we need from this one plate. Everything's there that we need, so we just need to transfer these measurements across to our own sketch. So let's go and make a new part. Don't know why I double click that. A sketch on our front plane and create our block, which is 50mm wide by 80mm high. Let's get rid of these. And we've got 1, 2, 3, 4 there, and obviously our bearing hole. Now the dimensions radiuses of these are 5.2, I think, if I remember rightly. Yep, 5.2. So we can go and change all these to 5.2 divided by 2, which is 2.6s. There's probably an easier way of doing this, but that's how I've always done it, so probably going to stay that way. And these want to be 10mm from the centre. And they're also 10mm from the edge. The distance between here is standard, which is 20. This is going on C-beam measurements, and that's also 20. And the distance between there and there is also 20. So that's our bolt holes all in the right places for our C-beam. Now we need the bearing. What dimensions have we got for the bearing? We've got 32.4 in and 11.18 in radius. So let's make that 32.4, and the radius, not that, thank you, The radius is, did I say 11.18? I think 11.18. 11.18 divided that by 2 gives us 5.59. Now I don't want a 50mm plate, so it's bigger than the actual C-beam itself. So I'm going to cut this down to 40mm, which is the same as the C-beam. And you'll now notice how close that bearing plate, well, the bearing here, that is just for, that is for the actual acne rod to come through. So by the time the bearing is on top of that, it's going to be even bigger. So I'm going to take this and probably bring this out to about 12.5, which brings it out there. And we best trim a few bits off now. That one and that one. Now you know why, when looking through the open builds and other people's builds, why that edge is roughly the same. There is not really much more you can do with it. Now the plate at the bottom, I'm going to add that. Now remember, I'm just going to anchor that down before I forget, otherwise it moves everything. And the plate we're going to add here was 20mm high, and because we've got an 80 plate already and a 20, that's 100. Now I'm going to make the width for this exactly the same, which is going to be 100. And now we can trim off the bit we don't need, which is there. So our plate is now taking shape. Now we're going to be using eccentrics in here, so again, let's add some eccentrics, what we're going to have. And again, same size as the rest, they want to be 2.6s. And we're going to make them 10mm from the edge. That's a good guess, seeing as that one is. And the same with that one, which is 10mm. And what have we got left there? Well, from there to there we've got 80. So if I went across about 30 and on that one 30, that's probably a little bit too much, so we'll drop that down to 25, that one down to 25, which then leaves us a big one in the middle. 27.5, that's got to do it. That's better, just evens them out a little bit. And then of course we need to be 10mm from the edge, so it makes it in the centre of them. That one's okay. Oops, done that wrong. Go back to our dimensions. Dementia, that's what I'm looking for. Make that 10, which will move, should make that one about right, yeah. So now that's them, those all centered up. Now remember, I've got a block going in here, but first of all I've got my substrate. So we'll change that to geometry, make sure that's anchored, and then my substrate is only, what is it, 10 mil that's going on the top there. And then the edge of one of them corner blocks is 20, so 20 and that 10 makes 30. So we need our corner block coming down here at a 45 degree. So let's have an angle of -45, and we should, of course he's got it the wrong way, try that again, 45 degrees instead. There we go. Bring us down there, and once again trim off the excess. So let's exit the sketch now. It's looking pretty much like what we want. Yep. Just going to go back in there now, and let's round off a few of these corners. Yuck, I don't want that much. About 2mm would be fine. So that one can be rounded off, that one. I think they'll probably round themselves off anyway then. Or should we put it in just in case? Smoothing them corners off, what do you reckon? Ah, what the hell. They're in now. So that's our corners all rounded off. Pretty much how it wants to be. So let's exit the sketch, go across, and we'll extrude that. Well, I would do if I chose something. Select a plane, this one. Ah, dafty me. That one then. Extrude that, and I'm going to be using 6mm plate on the end. Starting to look like a part now. Yep, right then, so what do we need on top of that? Well, let's recess all of these bolt holes. So let's go create another sketch, and we'll drop another cycle over each one of these. And what size are these that we need? Well, that's going to come across on something else, which is them. And they are 9.2. So let's swap all these over to 9.2. Divide that by 2 because it's radius. I've forgotten that number already. 4.6, that's it. 4.6, 4.6, 6. I wonder if I could do Control Select and then change them all at the same time. I don't know. Right, so that's them all 4.6. Let's come out of the sketch. Go to our features, and then we're going to extrude, cut all them. Now the normal measurement is 1.5, but I'm actually going to go down 1.6. If there's any deviation at all in the M5 bolts that I get, then it will still cover it. Click OK, and there we go, nice extruded there, extruded, I got it right. Now we need to put the bearing in there, which is the other side. So let's create another sketch, and a nice little circle, and the size of that is 16.1. Let's go on there, and that's going to be 16.1, obviously divided by 2. Exit the sketch, and it's a 5mm bearing. Well, I'm unsure whether I want to do it 5mm because it only leaves me 1mm the other side to hold the bearing. I'm actually going to take that down 4mm. In fact, no, 4.5. Yeah, 4.5. I'm going to take that down. And there we have the first front plate complete. So all we need to do is save this file, and then we can create an image of this file, and we have both of our front plates complete. Now for the rear plates, we're going to need to put the holes back in to mount the stepper motor on, but I want to use 4 brackets. So here's a quick and easy way of doing that. So first of all, let's create a new part. Go into the sketch, and we're going to put a couple of lines in. And change them to geometry lines and anchor them down. Now if we take a look at a stepper motor, you'll see you've got all the information that we need there, which is going to be for sort of like 57 max there, and we've got the dimensions between the holes. So if we go back to our part, we're going to need four holes for the steppers, and they're going to be 47.14. From there to there is 47.14 divided by 2. This gives us 23.57, and we need that between every part of it. 3.57. Phew. Gotta be an easier way. And that's them all spaced out. Now the holes, they're normally, if you're going to thread them in using the M5, you really want to be doing them, I think it's about 4mm, I think, I'm not 100%. But I'm going to have the bolts going through mine, so mine are going to be, well, my holes are going to be for M5s, which are going to be 2.6. So I'm going to change them. And then we want to put a box around the outside. Starting to look like a stepper motor now. And we'll make them, well, a stepper motor is 56, it says 57 max, so we're going to make it 58. Well, I'm going to make it 58. 58, and the same with view there, 58. Right, I can go along, delete these lines now. them, we don't need them at the minute. Now if I select everything, go to edit, copy, go back to our plate that we had, go into the sketch and then do paste. And that will bring us up there, which obviously you can see is in the wrong place. Straight away move entities, and we'll move the centre point over our bearing hole. Zoom in, and now we can start trimming off what we don't want. Yeah, we don't need that either. It's basically all of it. And that's it, that's them all gone. The 2mm, just redo our corners. There we are. Exit the sketch, and we've now got a bearing plate. Now because I'm doing mine different on here, instead of the bolts being threaded in, I'm actually sinking my bolts in from the other side. So I've got to create a new sketch on here and add purely for the stepper some little recesses for the bolt heads, and the size of them were, was it 9.2? I can't quite remember now. Let's have a look. Oh, let's exit out of there for a second. I got some on this side. 9.2, that was it. Let's go back and edit that. These were 9.2 divided by 2. 4.6s, right? 4.6. 4.6. 4.6. And okay, doing that again, are we? These want to be 1.6 to keep in with the others. That's them recessed on the back. And that's it, that's the, I can just mirror that now. And well, that's all four corners complete. So I'm going to go ahead and I'm going to print all of these out now. I'm going to save all the files. So I've got a right bearing, left bearing, right stepper plate, left stepper plate, and I'm also going to save them out as STL files and run them through the 3D printer. So see you in a minute when they're printed. Well, that's everything printed with the addition of a C-beam mini wheel plate. I've checked all the bearings and everything in the other plates, they all seem fine, and I've assembled one of the stepper motor plates. So let's get on the mod machine and have a look. Well, that's the brackets all fitted. They fit absolutely perfect. Line up, bearings fit in. I've put some acne rod in and the mini wheel plate to give it a good old DeWalt test. Let's have a go. Well, as you can see, everything runs really nice and smooth. I'm happy with the corner blocks. Now the idea originally for doing them in 3D print in plastic was, if I change my mind, then I haven't wasted any aluminium. But anybody that knows me, to hear me say I'm happy with them, they know it, you know, I'm happy with them, because I'm always changing my mind. But I'm that confident with these and happy with them. I think we're going to cut these out of aluminium and get them sat on the machine. They're not going to change, but that's not going to be in this video. I'll see you soon. So there we are then. That's the front front brackets. Not all that much went wrong in making this video, but I thought I'd just show you. How many corner brackets did I print? Yeah. Just gonna burn these now.